Okay. Good evening, guys, everyone. Right. Good evening, guys. Yeah, Vijay. What about you? Good evening, Bhargavi, Narayana, Saumya. So, any doubts, guys, from the last class? Any doubts? Yeah, good evening, Alam. Good evening, Krishna. Okay. If no doubts are there, we'll proceed with today's agenda. Today, let's go with the main topic, reference lines, trend lines, analytics, bands, distribution bands, all these things. Okay, yeah, good evening, Anusha. So let's go with main topic and let's proceed further. We'll have a quick recap on filters. So we started working with filters topic. What is a filter? It's on or off? Off. You offed it or okay. 50-50. We'll on it 8:15, 8:20 somewhere. Okay. Hmm. So let's go with the main requirement, filters. What are filters? Filtering the data. If in case you want to filter the data based upon one specific condition, you can proceed with this filters. I just want only one country. I want one category. I want these subcategories. Then we can provide one filter condition. And based on that filter condition, you can able to get that output. Now, when you're working with filters, you're having two different types of filters available. So data source filter, worksheet level filters. If in case you're working with data source level filter, you're getting again two types. Data source extract. And in worksheet level, you're having four different filters. Dimension filter, measure filter, cascading filter, and quick filter. So when you're working with data source level filter, data source level filter is there. And then we are having extract. The main theme here in data source level filter is, if in case you're providing any filter condition in data source level, that is going to be applicable to all the worksheets. That filter condition is going to be applicable to all the worksheets available in Tableau workbook. If in case you're working with worksheet level filter, that filter condition is going to be applicable only to that individual worksheet only based on your requirement. So whether you want to apply that filter condition for all the worksheets or whether you want to apply that filter condition only to that individual worksheet, that is something you need to select manually. So when you're working with data source level filter, data source filter is there, extract filter is there. If you remember the last 10 minutes of yesterday's session, I explained you difference between live and extract connection. When you're working with dynamic data, live and extract connections are there. Live data itself is nothing but live data. If I'm purchasing 5 orders, that 5 orders data is being inserted into Excel file. The same data needs to be lively updated in Tableau. But when you're working with extract connection, you are importing that dynamic data only, but based on schedule time frame. Today, say for example, morning 9 o'clock, you'll pull that entire latest data. You'll start working on it. And till night 9 o'clock, you're not selecting anything. But 9 o'clock, again, you're pulling the data. That is one part. Performance is going to increase in extract comparing with live. Why? Because in live, 24/7 queries are going to run in the backend. That is not the case with extract. And coming to worksheet level filters, you're having dimension filter, measure filter. If in case you want to provide filtering condition on a dimension categorical data, drag and drop dimension onto filter, you call it as dimension filter. If you want to work with filtering condition on any numeric data measure, drag and drop that measure onto filter card, you call it as measure filter. And there are two more filters available. What are those two filters? Quick filter, cascading filter. Quick filter is nothing but quick reference. If in case you want to filter the data quickly based on any selection, you can go with quick filter. If in case you want to provide it based on cascading filter, connection two filters, based upon that connecting filters, you need to get that output. Cascading filter is that. Okay, this is what the output that we'll be having. Now, let's go with main requirement. Today, we are going with a new topic called analytic section, and we are going to cover custom. Yesterday, I guess last 10 minutes, we worked with reference line, I guess, right? No, not yet. Okay, no problem. Today, we'll go with this topic. Okay, just try to explain me what is the purpose of utilizing these options, custom options in Tableau. Okay, I'll give 1 minute of time. Customizing. Hmm. Hmm. I guess tell. Okay, you can use Google or in. Hmm. Hmm. See, when you're working with this custom option, you'll be having 4 subsections in it: reference line, reference band, distribution band, and box plot. So when you're working with these 4 options, first thing first, let's go with the requirement. If in case you're working with reference line, you're trying to go with one simple line, and you're just taking that line for reference purpose. See, when you're having the simple problem statement, I'll go with this requirement. Category is there. Drag and drop this category on column shelf. Drag and drop this sales on row shelf. Change the mode from standard to entire view. Add these labels and sort the data ascending to descending. Instead of category, better I'll consider utilizing segment. How many segments are there? 3. Home office, corporate, consumer. Now, what is the total sales that we are generating from each and every segment? Home office 4,29,000, corporate 7,06,000, consumer 11,61,000. If in case I'm asking you, what is the average of all these three segments. What is the output, guys? If in case I'm asking you what is the average of these three segments, somewhere you will be adding 4 lakh 30 plus 7 lakh plus 11 lakh by 3. You'll get one average, and that average data point that you will be taking as a line. What is the concept that we are going to cover now? Reference line. Now, what is this reference line? You are just going to draw one simple line, and that line you are going to utilize it for reference purpose. Above to that line, what are all the categories? What are all the segments that you are having? Those segments are above to that average. And what are all the segments that you are having below to that average? Those are the segments below to this average. And now, the simple requirement, whatever the sales is there, based on that average, I want to try to consider one simple reference line. Instead of data, just beside to this, you are having something called analytics. And here you can able to say this option called reference line. No need to do anything, drag and drop this reference line. Simply provide it on table. Three options are there: table, pane, as well as cell. Drop it on table. Again, you'll be getting three options. See, these four options are these four options, guys. Line, band, distribution, box plot. Line, band, distribution, box plot. First thing first, let's go with line, reference line. In this, we'll be having three options available: entire table, per pane, per cell. And here, I'll go with each and every option in detail. I'll select this entire table. I'll go with this option called line. Based on this total sales, what is this computation that you're working with? Average. Are you getting this average line in the back end, guys? Whether you can able to see this average line. Total three segments are there. And if in case you are taking the average of all these three segments, this is the average line. And here, when you're working with this computation, what is the label name that you are getting here? Average. If in case I want to provide it with a value, instead of computation, I want to provide it with a value. Select this computation and just provide it with value. Whether you can able to see this value now? 7,65,734. But if you are simply providing value, whether the opposite person will able to understand what you are trying to convey? No. So it's better to include both computation as well as value. So just drag this particular option, custom, and utilize both computation and then value. Now, whether you can able to see both the computation name as well as the value name. If in case you want to provide some space, provide some space. Space, colon, space. And just get that output. Line, fill above, fill below. If in case you're working with this line, you can just play with these options. You want dotted lines, you want a straight line. Line, you want to increase the thickness, all these things. And then you can just play with this colors of these lines also, no problem. This is your average line, right? This is nothing but average of all these three segments, right? About to this average, if you want to color code it with green color, you can just utilize this fill above and provide it with green. And just down to this average line, you want to provide it with red color, provide it with red color. Now, just by looking into this visual, you can able to understand whatever the segments that have been provided in green color, green. Whatever the segments that have been provided in red color, it's in less than average. So this is how we can able to work with reference line. See, among these three, what is the minimum sale? Home office, right? Instead of average, if you'll select minimum, see, line is changing. What is the maximum here? Consumer. Instead of computation minimum, if you select maximum, maximum. So based on your requirement, you need to just select this option and you need to get that output. Clear? Let's check this out. Clear? Okay. Now, let's go with one more important requirement. I'll select category here, category here, and then I'll add subcategory, and then we'll go with total sales. Standard to entire. How many categories are there? 3. What are those 3 categories? Furniture, office supplies, technology. And in each and every category, you are having subcategories in it. For each and every category, you are going to get subcategories in it. In furniture, 4 subcategories. In office supplies, you are having close to 9 subcategories. And in technology, 4 subcategories. Total 17 subcategories are there. Now the requirement is simple. I just want to get that output. I just want to find the average for all these 17 subcategories. So what I'm going to do now, just go to analytics and utilize this option called reference line, drag and drop on any of the section. You're having 3 subsections: table, pane, cell. Just go with this first option, table. And there is this entire table. For time being, it's okay. Click on OK. Are you getting one average line, guys? And what is his average line? This average line is going to explain you what is the average that you're getting for all three categories. What are these three categories that we are getting? Furniture, office supplies, technology. And this average itself is something we are getting for all three categories, all 17 subcategories. But what if my question is, I want to get average for each and every individual category. Here, just utilize this edit button so that you can easily able to understand. Edit reference line. And here, instead of only computation, I'll go with computation and value. Okay. I'll go with both computation and value. What is the average that you're getting here? 1,35,000. And this 1,35,000 is the average that you're getting for all three categories, right? What are the average that you're getting? This is something that you're getting for all three categories: furniture, office supplies, technology. But what if I want average for furniture, average for office supplies, average for technology? Then what we are going to do now? Simple, right click, edit reference line. Instead of utilizing entire table, now go with per pin. Now, are you getting average for individual category? Now, this 1,85,000 is something average for only category furniture only. This 79,000 is the average that you are getting for only office supplies category. And this 2 lakh is the average that you are getting only for technology category. So you need to take a call whether you need to proceed with all or you want to proceed with only one. Earlier, if you are selecting entire table, that is something going to be applicable for all three categories. But now, for each and every individual category, what is the average that you can able to get? Based on that, again, you want to add some colors, you can add some colors. Fill below, fill above. Clear? And then there's one last option called parcel. So what is this parcel? So for example, right click, edit reference line. See, if you are going with entire table, you are getting that average for all three categories. If in case you are selecting per pen, you are going to get that reference line for individual category. What is this average for furniture? What is the average for office supplies? What is the average for technology? You are going to get it individually. But if in case you are working with parcel, what usually happens? For each and every individual column, you will get that value. Okay, individual column in the sense, for bookcases, what is the average? For chairs, what is the average? Got my point? In the first scenario, entire table for all 17 columns are getting average. But in second scenario, per pane, for these three categories, you are getting these three averages. But when you are going with parcel, what usually happens? You are going to get that average for each and every individual column. So based on your requirement, you need to pick a call and you need to understand the data. Whether you want to go with table or pane or cell. Clear, guys? So now let's go with the second requirement called band. What is this band? Band is something based on two options available, band from, band to. Again, three more options are available, entire table, per pen and per cell. If in case you're working with band from, what is the starting point? And when you're going with band to, what is the ending point? Okay. Earlier you are utilizing reference line. You are just taking one line, utilizing that line above and below. But here when you are working with band, you are going to take a band range, min to max. So for example, for entire table, for all 17 subcategories I'm working with, band from is nothing but what is the starting position. Band to is nothing but what is the ending point. Starting point, I'm providing it with an aggregation minimum. Ending point, I'm utilizing it as maximum. That means from minimum to maximum, whatever the output that you are getting, you will get all these subcategories here. These are all the subcategories that you are having. The minimum is something starts with fastener and ends with the maximum phones. Are you getting that entire volume filled with one simple color, guys? Simple. Now, let's go with per pin. Let's go with per pin. And utilize this per pin and utilize this option band from, band to. In band from, value, you are providing it as minimum and you're providing it as maximum. Here, just try to understand in this furniture category, what is his minimum? Bookcases. What is his maximum? Chairs. From min to max, are you getting this range? Here, the minimum is fasteners, the maximum is storage. Between min to max, are you getting the data range? Here, what is the minimum? For copiers. What is the maximum? Phones. From copiers to phones, are you getting that entire range? This is what you need to select, guys. What is the starting value? What is the ending value? What is the minimum? What is the maximum? Based on this range, you need to get that output. Simple. Clear, guys? And then the same thing goes with parcel. But I don't want from min to max. I want it something from minimum, average to minimum. What I'll do? Here I'll select average and then here I'll select minimum. Are you getting that output? From average to minimum. No, I want from average to maximum. Band from starts with average, band to try to provide it with maximum. From average to maximum, you will get all this band restriction data point values. Simple. And this is how you will be getting the output case. If in case you want to provide it with any color, you can provide with color. And based on that, you can just click on OK, you can get that output. Clear, guys? Just check this out. Yeah, someone on the AC right back. Switch. Direct or it's working direct. Hmm. Clear? Then there's last option called distribution. Line is there, band is there, distribution is there. Now, here you can work with these three scopes, entire table, perpen and parcel again. But here the requirement is a little different. Value, I'll try to select the range, the value. 60%, 80% of average, 10%, 20% of the average. Just you need to consider the value and you need to work with it. See, simple use case, the simple requirement, the simple problem statement. Value here, I'm providing it with 60%, 80% of average. It's fine. What exactly it means? What exactly it means? 60%, 80% of average mean. See, you are taking consideration of average. Somewhere, if you'll take this average value here, for all these subcategories, if you are taking average, somewhere if you are getting average line here, we call it as 100%. We call it as 100% line. Now, if you are considering this average line itself is your 100%, this is your 80% and this is your 60%. Agreeing with this, what I mean to say? See, requirement is simple. I am taking consideration of average. Somewhere I'll be getting this average here. Are you getting this average here? Yes. If you are taking this average here, if you are assuming this average itself is 100%, this in itself we call it as 60 to 80% of average, right? Got my point? And if someone is asking you, what are the subcategories that have been falling in this bracket, 60 to 80% of your average? The simple answer I can provide it with furnishings. So if in case I want to get those subcategories which are falling in between the range 20 to 50% of the average, what I'll do, I'll just select this option value. Instead of 60, 80, I'll provide 20, 50. Percentages, percentiles, quantiles. Quantiles in the sense box plots. Are you getting 20% to 50%? If you are considering average itself is your 100% somewhere here, now based on this, you'll get the output. If you are considering this in itself is this average, this is your 100%. 20 to 70, 20 to 50% has been provided here. Simple requirement. And based on this, you'll get that output. Clear? Right. So whether you want it based on percentage, 10 to 20 or 50 to 80, you can select and you can work with it. And the same thing that is going to be applicable again for per pen, per cell. That means instead of utilizing the same option for all subcategories, if in case you only want to work with one particular category section, just utilize per pen for individual category, you can able to get these values and you'll get that output. Simple. And this is how you can able to get this output case. And the same thing, the last option we are having, parcel. If in case you are working with parcel, you will get that individual column. For that individual column, you can able to get that output. Clear, guys? Okay, let's check this out. Let's go with box plot 2. Mm, mm, mm. 20 to 50%. That is something again based on average selection we will be doing here. If in case you want to go with percent of max, select max, and then you need to select that range value. If you want it based on minimum, minimum. Okay. So here you need to select that computation. Okay. Now just check this out, box plot. Directly, you might not get that option activated, box plot. The same box plot that you can able to utilize here in show me panel. Utilize that box plot for subcategory wise total sales. Subcategory wise total sales box plot. Done, completed. Okay. Online participants completed. Right. Then let's proceed further. Simple requirement, category wise, subcategory wise, total sales, total profit that you can able to get. You can put a filter based on reference line or based on reference band or distribution band based on entire table or per pane or per cell. All these options are completed. There is one thing called box plot. From visual level, you can able to use this option, box plot. So what we are going to do. So for example, subcategory is there. Drag and drop this subcategory. Drag and drop sales. Standard to entire view. Okay, standard to entire view. And just utilize this option, sort the data. And instead of this, I want to go with box. Presentation mode. Total 17 subcategories are there, right? All those 17 subcategories are been provided here. Are you getting 17 bubbles? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay. Now, this visualization is going to explain you. This visualization is going to explain you what is the distribution of data available based on quartiles. And if in case you will be having any outlier available in the data set, that outlier is something that you can able to get. See, when you're working with box plot, as I just explained you, You're having quartiles in it. This Q1, Q2, Q3, Q4. Sorry, Q1, Q2, Q3. These are lower bound and upper bound ranges. Lower bound in the sense we consider this value to be 0%, 0%. Q1, 25%, Q2, 50%, Q3, 75%, and then finally upper bound 100%. And then we work with one concept called IQR. IQR stands for IQR stands for interquartile range. What is the formula for IQR? Q3 minus Q1. Q3 minus Q1. What is Q3? 75%. What is Q1? 25%. 75% minus 25%. You are left with 50%. And that 50% of the data is median value, Q2. Q3 minus Q1. And that you will be getting 50%, and that is going to be our median value. Simple requirement. And that is what you will get in the output section. So here you can able to utilize all this sales whenever you can able to understand is there any outlier available in the data set or not. Those outliers might be falling somewhere like this. If any bubble which has been provided outside the bound, lower bound or upper bound, that is usually going to be our outlier in the data set. Clear, guys? If here we are working with this outlier, if in case you can able to see there's any data point provided outside this range, that is also we call it as outlier. So based on this, you can able to, anyone if ask you in the interview, what is the purpose of utilizing box plot visualization? You can able to explain in such a way that this is a visualization that explains you about the distribution of data. And at the same point of time, this is a very important visual to find an outlier available in the data. And there is one more visual too to understand an outlier available in the data set called scatter plot chart. There is one more visual called scatter plot visual. Utilizing scatter plot visual also, you can able to get what is outlier available in the data set. These are the two visuals. Clear, guys? Let's get that output. Now, I hope everyone is familiar with this outlier topic, right? What is an outlier, guys? It is an extreme data point value available in the data set. If in case you are having any outlier available in the data, it's better to replace that outlier with mean or median. Median? Online participants? Median. Okay, good. Mean itself is sensitive to an outlier available in the data set, whereas median is not sensitive to an outlier. So it's always best practice to pick median instead of mean. Okay, right. Now, let's go with the other subsection of analytics. Here you can able to see these options, guys. In analytics space itself, model options are there. Average with 95% CI, median with 95% CI, trend line, forecast, cluster. Okay. I'll just go with this option called trend line. What is the use case when you are going with trend line? See, what is the purpose of utilizing line chart? To understand the trends and patterns in the data set. Here, I'll go with this approach. I'll select some data, order date, and then I'll go with this data sales, standard to entire view, add these labels, and then just go to analytics section. And here you can able to see this option called trend line. Drag and drop this trend line here. There are five options available: linear, logarithmic, exponential, polynomial, and power. I'll explain you with month level hierarchy. Instead of year, quarter, I'll go with month level of hierarchy. In case you want to go with quarter, it's okay. Yeah, your wish. Drag and drop this trend line on linear. Are you getting one straight line, dotted line? See, whatever the blue color line which is fluctuating, that is usually a normal trend. But whatever the dotted line that you are getting, that we call it as trend line. That we call it as trend line. Now, here itself, this distribution, we call it as linear distributed curve. Linearly, a straight line itself has been drawn, and just that line explains you whether sales is going to increase or it is going to decrease, the trend. That linear trend line is not going to change its direction. It is not going to mold. It just provides one straight line. If it is positive, up direction; if it is negative, down direction. Linear curve. In case if you are going with the other distribution like exponential, a slight change shift is there. Why? Because here there's a dip right in the month of August. Considering those things, a small dip has been provided and that values have been adjusted. If in case you're going with the other part called polynomial, again, that is something working based on the curve, how the actual trend curve is changing, referencing that that line is also been changed. Clear, guys? So this is how you need to able to work with this options, trend lines. And there's the one more option called forecast. Okay, first let's complete this, then we'll go with forecast. Each and every model we are having, it's completely based on machine learning models, guys. So these are the topics we might not utilize more frequently as a data analyst: trend lines, forecast, clusters. But maybe you will utilize these options when you are going with data science and data analytics in the middle space. These are the things that these more concepts have been utilized by data scientist people. Trend lines, clusters, forecasting. These are all options. That is something we need to do with Power BI, Sura, the KPI part. Resource for Python, I'll suggest there's one website called W3 Schools. Python. Okay, W3 Schools. That is something you can just take a reference. Statistics. There's one book, guys. There's by one author. I'll let you know. Okay, but that much deep understanding, that book is not required for you, I guess. In that advanced topics, everything machine learning related algorithm parts up in there. Understanding for basic descriptive statistics, Google itself is enough for stats. But for Python, I'll suggest you to go with W3 schools. Okay. Right. Okay, done. Now there's one more option called forecast case. What is this forecast option is all about? Just utilize this, drag and drop this feature, utilize this concept based on forecasting. Requirement itself is simple. What I'm going to do is year-wise total sales. So for example, I'll go with this order date. I'll utilize this order date in column shelf. And here I'll utilize the sales onto row shelf. Change the mode from standard to entire. Add these labels. How many years are there? 4. 2014, 15, 16, 17. 4 years have been there. For each and every year, the total sales itself is changing from 4,84,000 to 4,70,000, and it got again increased to 6,09,000, and then again it got increased to 7,33,000. Okay, so these are the 4 years year-wise data itself has been provided. If in case you want to forecast the future, then you just need to drag and drop this forecast option. You'll get this value. You're having 4 years of data set. 2014, 15, 16, 17. And there is one last year called 2018. And whatever these years have been provided from 2014 to 2017, it's been provided with red color. And this blue color has been provided with blue color. So just take this understanding. This forecasting itself is going to explain you. Maybe for the next 2018, the sales might be stable. That means from the last 4 years, it might decrease or increase. Some fluctuations are there. But maybe for 2018, the sales trend itself is a stable part. If in case you want to understand that sales trend, forecasting trend, there you can able to utilize these extra options. Right click on it. There is something called forecast. Forecast options are there. And here you can able to utilize these two. Exactly until. Utilizing these two options, you can adjust these years and you can start working on the analytics part. Most of the students, what they'll commit a mistake here is while forecasting, they'll be utilizing multiple years. 4 to 5 years data is there. So for example, 2 years data is there and they'll predict for next 4 years. That is not the way you need to do. If in case you're having 4 to 5 years, predict for next 2 years. It's okay. Predict for next 1 year. You are having 10 years of data, guys. Predicting for next 2 years is okay based on last 10 years data. But if you are having 2 years data based on last 2 years data, predicting for next 10 years is not the correct way of approach. So you need to have a large data set when you're working with forecasting part. You need to get multiple years of data, multiple decades of data. Then predicting for next 4 years or 5 years, it's okay. No problem in it. I hope it's clear, guys. This we call it as forecast. So this particular section, these options are not really important, guys. But for as an add-on, just I'm going to explain this. This is not in your syllabus, but just maybe if in case you are going with any data science related interview, the questions you can expect. Trend lines of forecasting or clusters, CI confidence interval. Okay. If in case you're working with cluster, you're dividing that entire data into segments, clusters, categories. What exactly I mean to say is, see, here you're working with this data. What is the data? I just want to utilize subcategory, or else I'll go with one simple scatter plot chart. Sales versus profit data. I'll drag and drop sales onto column shelf and I'll drag and drop profit onto row shelf. Just change the mode from standard to entire view. And here you can able to utilize this values. By default, you are getting one bubble. What is that one bubble, guys? This one bubble is going to explain you what is the total profit and what is the total sales. Simple requirement. This one bubble is going to explain you what is the total sales and what is the total profit. The total sales that you're getting is 22,97,201 and the total profit that you're getting is 2,86,397. Based on your requirement, you need to get that value. Okay, fine. You're getting total sales and total profit. Well and good. Now, I just want to disperse this entire data. I don't want to perform any aggregation on it. What I'm going to do here, option itself is their values. You are getting lump sum total sales and total profit. Instead of performing any aggregation, just go to analysis, uncheck this option. Okay, you are removing aggregation. See, now are you getting the dispersed data, guys? Earlier, entire total sales and total profit has been provided in one single bubble. But now, multiple rows are there, right, for sales and profit. Each and every row itself has been represented with each and every bubble. Simple. So based on that bubble, you can easily able to understand what is the total sales and what is the total profit. Based on this requirement, you can able to understand the data. If in case you want to divide it based on clusters, go to analytics, drag and drop this cluster onto cluster section. By default, you are getting 3 clusters, 1, 2, 3. If in case you want to provide 10 clusters, try to give it a number called 10, you'll get 10 clusters. If in case you want to provide it with 6, provide it with 6, you are going to get 6 clusters. Clear, guys? So how many clusters that you want to create? That many values that you need to provide here, and you just need to get that output. Simple requirement. So total of 6 clusters are there. This is the first one, the second, the third, the fourth, the fifth, and then finally sixth. Clear? For each and every cluster, what is the total sales and total profit that you can able to get here? But what is the main theme here? Usually this is something utilized by data scientists. What they'll do is they'll utilize some machine learning models in the backend. There are some machine learning models like KNN, K nearest neighbor, KMC, K means clustering. These machine learning models are something working completely based on clustering approach, distance formula. Let me explain you how these concepts have been utilized by data scientists. You are trying to segment the entire data in multiple clusters, right? Usually when you're working with any data set in machine learning, you'll utilize train, test, split the data. Training data, test data. Training data is something that you are going to utilize it for training purpose, training a machine. But if in case you're working with test, based upon training data, how machine learn, and that machine is going to utilize the test data and perform some accuracy results. So for example, 100 rows are there, guys. You're splitting that 100 rows of data into 80-20 split or 70-30 split. 80% training data, 20% test data. Now the training data, 80%, whatever the training data is there, that you are going to consider for utilizing to train the machine learning model. But if in case you're working with test data, remaining 20% test data is there, right? That 20% test data is something you're just going to understand the performance accuracy. Now, what usually happens is based on distance formula, if any new data point value is being provided here. So for example, assume this. It will try to take shortest distance for each and every cluster. This, it's going to be the shortest distance, okay? This, and then this. Whatever the shortest distance that you're having from the data point value to each and every cluster, it will try to draw. And whichever the shortest distance is there, that it will think that maybe this data point should fall under this category cluster. Got my point? So this is how this clustering options are going to work. And this is how those things have been utilized by data scientist people. Data points are going to be there. So for example, let me give you one simple case study. There is something called used cars data. Okay, used cars data is there. There is one column called kilometers reading. Kilometers reading. We are providing it into 4 to 5 clusters, 0 to 20,000, 20,000 to 40,000, 40 to 60,000, 60 to 80,000, 80,000 to 1 lakh. If a new used car, if a customer is trying to sell their used car, say for example, it clocked almost 60,000 kilometers, 58,000. Automatically, it will try to take a distance formula for all those 5. And it will think that maybe I need to fill in this 40 to 60 bracket. And obviously that value will go to that cluster. So based on distance formula, these things are going to work. And if you remembered, when you're working with statistics, sampling technique, clustered sampling technique, you're dividing the data based on some clusters. So this is how you can able to create a cluster in population data set. See, whatever the options that we completed today, if you can able to understand these are all options, it's more than fine, sufficient, well and good enough. Even though if you're having little confusion on these topics, no problem. Just try to understand these things a little bit. It's more than enough. Okay, guys, just check this out. Soumya, you need to go with this option. If in case by default you'll select sales and profit on scatter plot chart rows and column shelf, you'll get one bubble. If you want to get multiple bubbles, go to analysis on top and just deselect this option. By default, you'll get this checkbox, deselect this aggregate measures. You'll get that output. Clear, guys? Everyone? Any doubts? Online participants clear? Okay, right, guys. So, okay then. let's connect again tomorrow. Tomorrow we'll go with a new topic called joining techniques available in Tableau. We'll go with joins, relations, union, blending, and then we'll go with Tableau dashboards. And there itself we work with Power BI dashboard too, one more time. Okay. So, okay then guys. Okay, right, Alam. Great. Okay then, good night guys, everyone. Bye guys, online participants. Good night.